Hi friends, I'm Nagajyoti working as an assistant professor in Department of ECE and dealing with the subject of linear IC applications. So in case of a linear IC applications, the complete subject deals with a basic circuit of an op-amp. So in the units of 1, 2 and 3, we have discussed about the applications of an op-amp, how the op-amp can be used in different modes, and what are the different parameters of an op-amp. So coming to the unit 4, the complete unit 4 deals with introduction to 555 timer and what are the applications of a 555 timer, what is the pin structure and functional diagram of a 555 timer, and how the 555 timer can be operated in different modes. So the first is introduction to 555 timer. So here this 555 timer is a monolithic IC. So here mono itself indicates single. So it consists of both active and passive elements on a single silicon layer, and it is basically used in order to generate accurate time delays by using a 555 timer. And in case of a 555 timer, it is used in order to operate either in monostable or an astable mode, and this 555 timer will be available in the IC form with 8-pin package or 14-pin package, and it is having the capability to design for the operating ranges ranging from -55 to +125 degrees, and the supply voltage can be operated in between 5 volts to 18 volts, and it is having the capability for compatibility with TTL logic family. Now let us see the pin diagram of a 555 timer. So this is a 8-pin of a 555 timer. So the first pin is ground, by which we can measure all the voltages with respect towards this terminal, and the second pin is trigger. So here what is the meaning of a trigger and where we'll be using this trigger? So if the output of a timer depends upon external voltage, then we are going to use this pin number 2 into the consideration. So if the output is low, the voltage at this pin is greater than 2/3 VCC, and similarly whenever a negative pulse is applied which is having the value of greater than 1/3, again the comparator will be goes to low state. So here the general meaning of a trigger is whenever we want to move the change of a state from low to high or high to low, we are giving an external voltage. That external voltage is called as trigger, and the third pin is output. So here this output can be connected to the load in two different manners, that is either between pin number 3 and 8, or it is in between pin number 3 and sink current, that is whether the current is entering or leaving. Depending upon that, either it may be connected towards a plus VCC or a reset terminal. And the next fourth pin is a reset. So whenever you are pressing a reset, that itself indicates it is making the complete 555 timer to start its functioning from the initial value. That is a one way. Or if you are applying a negative pulse to this pin, automatically this will be going into a reset state, means making the output is equivalent to 0. And the next pin is control voltage. So whenever we are applying external voltage, so we need to apply external voltage through the control voltage. Here trigger is nothing but here we are giving a negative pulse in order to change its state, but the control voltage will specify imposing a voltage on this pin by connecting a potentiometer, so that we can use these for the variations of the frequency changes with respect to change in the amplitude of the signal. The next pin is threshold. So the meaning of this is once the voltage across that op amp is exceeding this value, the output should be 1. If it is less than this value, the output should be 0. So here threshold is a cutoff region between two values. And the last one is VCC, by which we can apply the supply voltages ranging from 5 volts to 18 volts. This is a functional diagram of a 555 timer. So here, in case of a functional diagram, if we observe this circuit, basically it consists of 4 different blocks. The first block is potential divider network. So in case of a potential divider network, it consists of 3 resistance values of equal value. So in general, all these 3 resistance values are having a value of 5 kilo ohms. That is the reason it is called as 555, as we are having 3 resistances of equal values of 5 kilo ohms. It is called as 555. So the first block is potential divider network. The second block is comparator circuit. Third block is flip-flop, and the fourth block is output or a buffer stage. So if we observe this, as we know that the first pin is ground, the second pin is trigger, which is connected towards the negative terminal of a lower comparator. Third pin is output. Fourth is a reset. Fifth is control voltage connected towards the upper comparator negative terminal, and threshold, and we need to have a discharge path. So here 7th pin is a discharge. So in order to understand the concept of this 555 timer, let us assume that the initial value of Q is equivalent to 0. If Q is equivalent to 0, the SR flip-flop is having 2 outputs, one is Q and the other one is Q bar. Then Q bar will be is equivalent to 1. If Q bar is equivalent to 1, then transistor will be in the on state. This transistor should be connected. This transistor is connected towards the inverter as well as Q1. So whenever the transistor is on, automatically it ons the Q1 transistor, and this 7th pin should be connected towards the capacitor over here. As there is no capacitor over here, let me assume that the control voltage which we are applying over here for the upper comparator is 2 by third of VCC, because here as there are 3 resistance, by applying a potential divider network, the voltage across the upper comparator is 2 by third VCC and lower comparator is equivalent to 1 by third VCC. And in order to get upper comparator equal to 1, the condition is the voltage across that corresponding pin should be greater than 2 by 3 VCC. So whenever the voltage across pin number 6 2 by 3 VCC is greater than 2 by 3 VCC, then only upper comparator is equivalent to 1. Similarly, in order to make lower comparator is equivalent to 1, the corresponding voltage should be less than 1 by third of VCC. So trigger value should be less than 1 by 3 VCC and control voltage should be greater than 2 by 3 VCC. Now let me assume that as the capacitor is present at the discharge path and there is no charge in the capacitor. So if there is no charge in the capacitor, itself indicates the value is equivalent to 0. So if value is equivalent to 0, can I say 0 is less than 1 by 3 of VCC? So if the input is less than 1 by 3 of VCC, lower comparator will be is equivalent to 1. That is, S will be is equivalent to 1. If S is 1, whatever may be the R value, the output Q of T value will be is equivalent to 1. And Q of T bar value will be is equivalent to 0. If the Q of T bar is equivalent to 0, the transistor will be off and the capacitor now also is not having the capability to perform charging operation. So here whenever the control voltage which we are applying is greater than 2 by 3 VCC, then R will be is equivalent to 1, because the upper comparator is 1 as the voltage is greater than 2 by 3 VCC. And when R is equivalent to 1 and S is equivalent to 0, it will perform an operation of reset. Means Q of T is equivalent to 0, Q of T1 bar is equivalent to 1. If Q of T1 bar is equivalent to 1, transistor will be in the on state, and if the transistor is in the on state, Q1 can also be in the on state because the same path is going to be passed through this. Then it slowly starts charging of the capacitor. So once the capacitor is going to be charged in this way, it will continue its process until the output is varying. Now, in order to get the working of this 555 timer clear, first we must know the flip-flop truth table. So when both S and R are 0 zeros, whatever the previous value which we have given for the upper and lower comparator will continue. If it is 0 1, that is S is 1, itself indicate set state. Similarly, when R is 1 and S is 0, it is a reset state. And if both are 1 and 1, then it is called as invalid state. This is how a 555 timer consists of, what are the internal blocks of a 555 timer, and how can we change the voltages with respect towards the external applied voltage.